Today, we'll be learning about sets. Sets is nothing but a collection of well-defined objects. It is just that you group all the objects with similar properties and then call it a set. For example, all these here have similar properties. That is, all these are numbers. So I can group it and call it as set A. All these alphabets here are similar to each other. So I just group it and call it as set Q. Over here, all these are numbers, and there's one more connection, that is, all these are even numbers like 2, 4, 6, 8. So I just group them and call it as set P. Giving a more mathematical example, we could just group all the natural numbers and call it as set N, or group all the whole numbers and call it as set W, all the rational numbers and call it as set Q, and many more. Even we could group all the students in your class and call it as like set A or anything. So this is basically what sets is. So now how do you tell that this D, that is this object or element or members, all these refer to the same thing. So how do you tell that this element belongs to Q, that is this element D is in Q? To do this, to denote the object, we use epsilon. Epsilon is a Greek alphabet and we read it as belongs to. For example, we have a set where P is equal to A, B, C, D, E, F. So how do I say F is in set P? I use this Greek alphabet. I just write F belongs to P. This epsilon should be read as belongs to. What if I say G? G is not there in set P. So I just strike the epsilon and read it as G does not belong to P. So this is basically how you denote an object in a set. Now just note that in mathematics, all the set name is denoted by capital letters, right? And all the elements are denoted by small letters. And element, members, objects, everything refer to the same, but just we'll be using elements in this chapter so that we don't confuse ourselves between all these terms. Now how do you represent a set? There are two types. One is roster form and the other is set builder form. So roster form is where you basically list out all the elements and put comma in between them enclosed in some flower brackets. Set builder form is where you just write the same thing in a statement. Let's see this with an example. For example, let's consider a set A, which is all the vowels in alphabets. To represent this in roster form, which are the vowels in alphabets? A, E, I and O, U. Okay, so now to represent this in roster form, you just name your set as A, B or anything. For example, even I can name it as Q, and then I just list all the elements with comma in between, right? Comma is important, and enclose them in brackets, flower brackets. Now this is basically what roster form is. Now coming to set builder form, you just have to make a statement, that is, you just have to write the relation between them. I'll just read out how do you call this. X such that. This colon is read as such that. So X such that. X is a vowel in English alphabet. X could be A, X could be E, X could be I, X could be O, and X could be U. Let me give another example to make this concept more clear. For example, take all the odd numbers. I could represent all the odd numbers in roster form like this. I'll take the set name as maybe B. And I can just first remember enclose in flower brackets, then which are the odd numbers? 1, 3, 5, 7 and so on. So remember, you have to enclose them in flower brackets and comma in between all the elements. So this is basically how you represent in roster form. Roster form is nothing but you just list all the elements and put comma in between them and enclose them in flower bracket. Simple. Then coming to set builder form, you just have to find the connection between them. What is the relation here? That is, all these are odd numbers. So how do I write in set builder form? Set B where X such that, X is just a variable over here, X such that X is an odd number. Is an odd number. To be more specific, you could also write that X is an positive odd number. But X is an odd number is also fine. So I hope you understood the basics of sets. Now let's move to examples. This is your example 1 in your first PU mathematics textbook. So what does the question says? Write the solution set of equation x square plus x minus 2 is equal to 0 in roster form. So first let's find the solution set for this. This is your basic mathematics what you learned. So first you write the equation. How do you find the solution? You have to find a number such that a into c, that is 2. You have to find two numbers such that the addition or subtraction will give you the middle term. So I could take 2 and 1. 2 ones are 2, and if I subtract 2 minus 1, I'll get 1. So write x square plus x plus 2x minus 2 is equal to 0. Group the terms. Now what is common? X is common. So x plus 2 minus 1 is common. So x minus 2. X plus 2. Okay. So now you will get it as x plus 2 and x minus 1. So your solution will be either minus 2 or plus 1. I'm just over briefing it because you have already learned all these. So now your solution set is minus 1 and minus 2 and 1. So they have asked you to write in roster form. What do you do in roster form? Just name any set, like keep it as A, and what will be your elements? Minus 2 and 1. You just have to list the elements with commas in between them. This is your answer. Simple. Next, write set of x such that x is a positive integer and x square less than 40 in roster form. So now they have told x is a positive integer and squaring it will be a number less than 40. You have to write it in roster form. So you have to list the elements with commas in between and flower brackets enclosed. So let's name any set. I'll keep it as B, flower brackets. So now x is a positive integer. So 1 square, yes, will give me 1 which is less than 40. So I can write as 1. Then again 2 square, yes, 2 2s are 4. Then 3 square, 9 is less than 40. Sorry, I should write it as 2, right? Sorry. Now 1, 2, 3 and 4. 4 square is 16, yes. Then 5 square is 25, yes. 6 square is 36, yes. But 7 square isn't. It's 49. So yeah, this much is your answer. Right? Next, write a set A is equal to 1, 4, 9, 16, 25 in set builder form. Set builder form, you have to write a statement. So what is the relation or connection in between these? All these are square of the numbers, right? So this is just square of the numbers. There are two ways to write this. Like either you could write it in an equation form or a statement form. I'll show you. Set A, they have given the set name also, so I'll just write it. Set A is x such that x is equal to n square. N could be any number, right? X such that x is equal to n square, where n could be any natural number because it starts from 1, not from 0. So x such that x belongs to natural number. Now, or else you could also write it as A such that x, or else you could also write it as set A is equal to x such that. Remember, colon reads it as such that x is what? X is a square number. X is a square. Well, you have to be very specific when you're writing. So x is a square, right? X is a square of what? All the positive natural numbers. Like natural numbers are always positive. You can write it as A is equal to, set A is equal to x such that x is a square of a natural number. Either of it will work. You could write it in any way. Like either you could use an equation or just write it in statement. Now coming to the next one, you have to write in set builder form. So you have to make a statement. So what is the relation in between them? You can see that first we have 1 and 2, then you have 2 and 3. Okay, and then we have like 3, 4, 4, 5. So to find the relation in between them, let me put 1 as n, okay. So what is happening to down? 1 plus 1 is 2, right? So n plus 1 is happening. Same way if I keep n as 2, n plus 1, 2 plus 1 will give me 3. So the relation between all of them is n by n plus 1. So now can we write this in set builder form? Let's take it as A. Set A is x such that x is equal to n divided by n plus 1, where n is a natural number. And did you notice another connection? That is, did you notice something else? That is, it is only till x. There is no 7 by 8 and all. So only till x. So we have to have only natural number till x. So you could write as less than x or x such that x is equal to n by n plus 1, where n is a natural number and n is less than or equal to 6 or greater than or equal to 1. You could just write it as less than 6, but this is also fine. So the next one is to match the following. So first let me write this all in roster form so that you could just match it more easily. So first they are telling x such that x is a positive integer and is a divisor of 18. Which and all are divisor of 18? Let's just name this as set A. The divisor of 18 would be 1, then the number itself, then it comes in 2 table, 3 table, then 6 table, and then in 9 table. Yep, that's it. It doesn't come in 10, 11, 12 or anything. Yeah. Next one, x square minus 9 is equal to 0. X square minus 9 is equal to 0, x square is equal to 9, and x is equal to root of 9, which is plus or minus 3. So your set A would be minus 3 or plus 3. And over here x is an integer and x plus 1 is equal to 1. So x plus 1 is equal to 1 means 1 will come this side, x will be equal to 0. So your set just consists of one element, that is 0. Now in the word principle, the letters would be P, R, I, N, C. Again we have I. We don't have to repeat the numbers or repeat the alphabets in a set. You could just avoid it. Even if you write it, it's not a problem, but it is more readable, more understandable if you don't repeat things. So P, R, I, N, C. I is repeated, P is repeated, A isn't, L. So now you can match it easily. This goes with this, and then 0 is this set, and then this one is matching with this one, and this one is this one. Yeah, so we are done with all the example sums. So that's all for today. Thank you.